Welcome pre-cal students to the homework help video, page 84, numbers 1 through 7, odd, 15 through 18, all, and then 21, 22, 25, 26, 27, 30, 31, 35 through 37, 39, and 40. Get out your books, homework, calculators, pens, pencils, and paper, and let's get started, okay? I went ahead and grouped numbers 1 through 6 together. They're pretty quick. And numbers 1 through 7, the directions say determine whether the relationship or correspondence is a function. So with that in mind, let's go ahead and get started. A has one output, B has one output, C has one output, and that's why the answer is yes. M has one output, Q, N has one output, S, O has one output, R, and that's why the answer is yes. -6 has one output, -2 has one arrow coming from it, one output, and 2 has one output. It doesn't matter if they share the same output, that's okay, as long as each input has one output. Let's take a look now at number 4. 3 has one output, but look right here, 1 has two outputs, and that's why the answer is no. Look at this at number 5. Right away it fails. M has two outputs, and it only has to happen once, students, for the relationship or the correspondence to not be a function, and that's why the answer is no. And then here A has one output, B has one output, C has one output, and D has one output, and that's why the answer is yes. Let's take a look now at number 7. Each one of these, I'm not going to go through all of this, but look, every animal has one arrow coming away from it. So that tells you each animal only has one output. So yes, definitely. I mean, every input has exactly one arrow or one output coming out from it, okay? All right, that's going to be number 7. Now let's move on to numbers 15 through 18. I grouped all of these together too because they're really pretty easy and pretty quick to do. Okay, so looking at number 15 here, 2 has one output, 3 has one output, and 4 has one output. So yes, this relationship is a function. 3 has one output, 5 has one output, 7 has one output. So yes, this is a function. -7 has one output, -2 has one output, -2, oh hold it, -2 gives me out a 1, and -2 also gives me out a 4. So no, this is not a function. Okay, 1 has one output, look right there, 1 has 4 outputs. 1 gives me out a 3, a 5, a 7, and a 9. So no, this relationship or correspondence definitely is not excuse me, sorry, it does not have a functional relationship. Let me get a drink of water. So, moving on, there is one other thing the directions asked you to do. I did not mention in your notes, but it says to identify the domain and range. So the domain would be 2, 3, 4. Remember, your domain is those interchangeable terms I talked about. Domain would be your x values, 2, 3, 4, and your range would be 10, 15, and 20. And it's that easy, okay? I'm not going to do all these for you. I'll jump down to one that wasn't a function. The domain would be, even though it's not a function, it still has a domain. -7, -2, and 0. No need to list the -2 twice. The range would be 3, 1, 4, 7. All of your y values. 3, 1, 4, 7. So domain refers to your x values. Range refers to your y values. Okay? And moving on. Now we're going to look at numbers number 21. And in these problems, they want us to evaluate the graph at the given number. Now, this is actually pretty easy, guys. I mean, I know the answers are right here in front of you, but look at this. Okay, first of all, they want you to evaluate h of 1. So let's find an ordered pair. Here it is right here. When you put in 1, you get out a -2. That ordered pair right there. So look what they put for their answer. H of 1 equals -2. H of 1 equals -2. The next one they want us to evaluate is a 3. So let's find an ordered pair that you're putting 3 into the equation. Right here. Here it is. You put in a 3 and you got out a 2. So you would simply say h of 3 equals 2. Plain and simple. And then lastly, they want us to evaluate h of 4. H of 4 equals, well, here's your ordered pair. You put in a 4, you got out a 1, so h of 4 equals 1. This is easy, but you're getting used to using functional notation, and you're also understanding what it means to put in a value and get it out when you're looking at a graph. All right, number 22, same thing. I'm not going to write these out for you. They're written right here for you. T of negative 4 is 3. T of 0 is 3. T of 3 is 3. Okay, we're going to talk about each one. Okay, they want you to evaluate T of negative 4. So here's the ordered pair. When you put in negative 4, you got out 3. So there's the answer right there. T of negative 4 equals 3. Next, they want you to evaluate T of 0. Well, here's the ordered pair. When you put in a 0, you got out a 3. So T of 0 equals 3. And then lastly, they want you to substitute in or to evaluate the graph at 3. Well, here's the ordered pair. When you put in a 3, you got out a 3, so T of 3 equals 3. Moving on to the next problem. Number 25. F of negative 1. Well, here's your ordered pair. When you put negative 1 in, you got out 2. So F of negative 1 equals 2. Next, they want us to evaluate F of 0. Well, here's the ordered pair. When you put in a 0, you got out a 0. So F of 0 equals 0. Pretty simple. And then we're going to evaluate F of 1. So when you put 1 into the equation, you get out a negative 2. So F of 1 equals negative 2. Okay, moving on to the next problem, number 26. G of negative 2. Well, here's your ordered pair right here. When you put in negative 2, you got out 4. So G of negative 2 equals 4, right there. All right, next, G of 0. Well, here's when you put in 0, you got out negative 4. So G of 0 equals negative 4. Next, we're going to substitute 2.4 in. And when you substitute 2.4 in, you get out negative 2.6176. So here's your answer right here. Sorry, let me get a drink of water here. We'll continue on. Do have a little bit of a cold, so I apologize. Number 27. Okay, now we're going to get into some work. Finally, they've been pretty easy up until now, and I only gave you 1, 2, 3 of those. This is really a pretty simple homework assignment. Okay, we're going to put 0 in for x. So 3, 0 squared minus 2 times 0 plus 1. 0 squared is 0 times 3 is 0. 2 times 0 is 0. 0, 0 plus 1 is 1. So the answer is 1. All right, letter B, let's substitute negative 1 in. Watch your signs now. 3, I put a negative 1 in for x. Negative 2, then negative 1 for x, positive 1. Okay, we do our exponents first, so a negative 1 squared would be a positive 1. Then next we do our multiplication. 3 times 1 is 3. Negative 2 times negative 1 is a positive 2 plus 1. So your answer would be 6. Okay, moving on to letter C, we're going to put 3 in for x. So 3 parentheses 3 squared minus 2 times 3 plus 1. So you do your exponents first. 3 times 3 is 9. So now I have 3 times 9, negative 2 times 3, positive 1. This would be 27. This would be negative 6. This would be positive 1. And you'll get out 22 if you simplify those correctly. All right, moving on to letter D. Negative x. So be careful. 3, then parentheses, then negative x, quantity squared. Then negative 2, then parentheses, then negative x, then positive 1. Alright, now you square your negative x first and think about it. A negative x times a negative x is a positive x squared. So you did your powers first, and now multiply. 3 times x squared is 3x squared. Negative times a negative is a positive 2x. Bring down your positive 1, and this is your answer right here. And then lastly, letter E. Letter E. 1 minus t. So 3 parentheses, 1 minus t, quantity squared, minus 2, parentheses, 1 minus t, positive 1. Okay? Now, first of all, you do your exponents. Don't forget, you cannot multiply this 2 through times the powers because you have 2 terms right here. And whenever you have 2 terms, you can't do that. Instead, excuse me, sorry, you have to write out 1 minus t 2 times, like this. Now, if you multiply all that out, 1 times 1 is 1, 1 times negative t times 1, negative t times negative t, positive t squared, you'll end up with this right here. 1 minus 2t plus t squared. When you simplify this, this is what you'll get right here. All right? And then bring down your negative 2 parentheses 1 minus t, and then a positive 1. Alright, let's go ahead now and simplify our first parentheses, multiply a 3 through. 3 times 1 is 3, 3 times negative 2 is negative 6t, and 3 times t squared is 3t squared. I multiply the 3 through the parentheses. Now I'm going to multiply a negative 2 through this parentheses. Negative times a positive is negative. Negative times a negative is a positive 2t. And I'm not sure why I put a t with that 2. I should not have. That's my fault. And so negative 2 times 1 is negative 2. Negative 2 times negative t is a positive 2t. Then bring down your positive 1. And then when we simplify, we'll put our t squared first. Cross that off. Now I've got a negative 6t and a positive 2t. That's a negative 4t. And then I've got a 3 minus 2 plus 1. That will give you a positive 2. And this answer here does match this answer here. All right? Moving on, number 30, okay? Now we have 2 absolute value of x plus 3x. Well, first of all, we're going to substitute 1 in. So 2 absolute value 1 plus 3 times 1. Now, 2 right next to the absolute value. Let me get a quick drink here. 2 right next to the absolute value of 1 means 2 times the absolute value of 1. Well, the absolute value of 1 is 1, so really I just have 2 times 1. Remember, absolute value means make the number positive or leave it positive. 2 times 1 is 2, 3 times 1 is 3, combine those and you will get a 5. Now let's try a negative 2. This will be a little more interesting. 2 absolute value negative 2, and then positive 3 parentheses negative 2. Everywhere there was an x, I substituted negative 2. Now the absolute value of negative 2 is positive 2, so now I have 2 times positive 2. So the first thing I did was take care of my absolute value. Next, I multiply. 2 times 2 is 4. 3 times negative 2 is negative 6. When you combine those, you will get a negative 2. Moving on to letter C. Now we're going to put a negative x in. So 2 absolute value of negative x minus 3 negative x. Okay, very good. Now first of all, the absolute value of negative x means 2 times positive x. Okay? So whatever we get out of this, we're going to get out a positive number. Now I will say one thing. Actually, I better be very careful here and see if you can understand my reasoning. I made a little mistake there. I don't want to go into great detail on this because it's really confusing, but I will try to explain this to you. You really need to leave the absolute values just like they did in their answer. Let me explain why. When you make this a positive x, that's fine. But remember, now watch this. Let's come off to the side. When I put a number in for x, let's say a negative 3, I first simplify. That would give me a positive 3, and then the absolute value of positive 3 is 3. Now let's put a positive number in for x and watch what happens. If I put a positive 5 in, I get out a negative 5, like this, and then the absolute value of negative 5 is 5. Now, if I would have left this parentheses, then that means whenever I put a negative 5 in for x, I would simply have 2 parentheses negative 5. Excuse me. If I were to put a negative, let me rephrase that, and I apologize. If I were to put a negative 3 in for x right here with parentheses, then it'd be parentheses negative 3, like that. And when you put a negative 3 in for x like I did here, you really should get out a positive 3. I just showed you that right here, step by step by step by step. So you can't put something over here with a variable that's going to change the answer. You've got to be very careful with absolute values. They're very tricky. So the best thing to do is just leave the absolute value, make the variable positive, and because these absolute value symbols are still here, no matter what number you put in for x, it will come out positive in the end because of those values, and you really want that, okay? Then over here we still have negative 3, negative x. So I'm not going to multiply this through. I'm going to leave it 2 absolute value of x, and then negative times a negative is positive 3x. And that's why they have, let's see here, did I make a mistake on this? Let's see. Yes, I did. See this positive sign right here? I just circled it. That should be a positive, that should be a positive, and that would make that a negative. I apologize. So this answer here matches this right here. All right, let's take a look now at letter D. Letter D, we're putting 2y in. So 2 parentheses 2y plus 3 2y. Now, I can see their answer right here, and I'm okay with that. Personally, I would have left it just like this. What they're doing there is they're saying this. They're saying, hey, no matter what you put in for y, you're going to end up multiplying it by 2. So if I just go ahead and distribute the 2 through and put a 4 and leave the y on the inside, it will give me the same thing because whatever you put in for y, you're still making it positive, and then you multiply it by 4. Up here, if you put a number in for y, you would multiply it by 2, make it positive, and multiply it by 2. It's the exact same thing, but to be honest with you, I have no problem with this answer right here, except we do need to simplify this part over here. So I would allow you to put this for your answer like that. That's totally acceptable, and their answer also is accurate. All right. Okay, let's move on to letter E. Letter E. Now, again, with absolute values, they can be a little tricky, and that's actually why I gave you this problem on purpose. I wanted you to experience this. We're going to, everywhere there's an x right here, we're going to substitute 2 minus h. So let's do it carefully. 2 absolute value, 2 minus h, close your absolute value, plus 3 parentheses, 2 minus h, close your parentheses. Now, obviously we can do this. 3 times 2 is 6. And 3 times negative h is negative 3h. However, this is a little tricky. Please do not multiply the 2 through. That is not correct to do that. Okay? Whatever we put in for h, because there's absolute values around it, let's say we put in a negative 3 for h. Okay? So you have 2 minus a negative 3. That would be 2 plus 3. That would be 5, the absolute value of 5. And so you would have 2 absolute value of 5, which would be 10. But if you multiplied the 2 through, you would have no 2 here, you'd have a 4 here and a 2h. And then be very careful here, because in this case here, I probably should use a different example. When you multiply negative 2 times negative 3, you're going to get a positive 6, and then multiply it or add to it a 4, you will get a 10. I should have used a positive number there, but you will not always, so not the best example to use, but you will not always get out the same number with absolute values when you have 2 terms and a number on the outside. So be very careful about doing that. I would leave it just like this, and that is definitely acceptable. All right. Let's move on. Let's move on now to number 31, and we'll be finished with the more difficult problems, and the rest of the homework's pretty easy. Okay, g of 5. Here's an x, here's an x. I'm going to substitute 5 in, and did not mean to do that. So here's the x's. I'm going to substitute 5 in for x, so I would have 5 minus 4 over 5 plus 3. That would be 1/8, and that is the answer right here, 1/8. All right, let's try letter B. We're putting in 4 for x. So 4 minus 4 over 4 plus 3. That would give you 0 over 7. And you're allowed to have a 0 in the numerator. That's fine. 0 divided by 7 is just 0. What you're not allowed to have is a 0 in the denominator. You can never divide by 0. Let's put negative 3 in for x now. Negative 3, negative 4 over negative 3, positive 3. And like I just said, you cannot have this right here. You cannot have 0 in the denominator. You cannot divide by 0. Put no solution, does not exist. They put does not exist, undefined, no solution. All of those answers are fine. Okay? Excuse me, moving on. Next we have negative 16.25. We're going to substitute in for x, minus 4, all over negative 16.25 plus 3. Now up here, if you take a calculator and combine those or do it in your head, you will get a negative 20.25. And down here in the denominator, if you combine these correctly, you'll get a negative 13.25. Now I can simplify this pretty quickly. You can move the decimal 2 places up top as long as you move it 2 places in the bottom, and a negative over a negative is a positive, so the whole fraction is positive, and you would end up with 2,025 over 13,025. Now I'm not going to take time and reduce that. I mean, quickly you can reduce it by 5, and you would get 405 over, let's see, 265. Well, maybe I will quickly reduce it. And then with 5, you would get an 81 over 53, and I think that's as far as you can go. But that would be the fraction reduced, or you can also type it in and get a decimal. One of those two answers. Alright, let's move on now to letter D, or E, excuse me, and we are finally finished. So for x, I'm going to substitute x plus h, and then negative 4 all over, and then for x, I'm going to substitute x plus h, positive 3. Now, there's really like an imaginary 1 on the outside. If you want to put that, 1 times x, 1 times h would be x plus h minus 4. And then 1 times x, 1 times h would be x plus h plus 3. Now, this is your answer. A lot of students want to cross the x's off, sorry, and cross the h's off. And that is unacceptable because you have more than one term up top and more than one term in the bottom. Now, if you had 4xh, that's one term, negative 4xh over 3xh, that's one term over one term, then you are more than welcome to cancel your x's and cancel your h's, and your answer would be negative 4/3. But you cannot do that in this problem because we have more than one term and more than one term. Okay, and now the last ones are really fast and really easy. So 35, 36, 37. I don't think you were supposed to do 38. I just had to cut and paste it out of the book, and so it was hard to leave off 38, so just ignore number 38. Okay, vertical line test. Does this graph, number 35, represent a function? Well, if I can draw a vertical line anywhere that intersects the graph in more than one place, it's not a function. Well, I can draw a line here, and that vertical line hits the graph here and here. It only has to happen one time. Okay, I can draw a vertical line here that hits this graph here and here. Almost to your heart, I can draw a line here that only hits the graph once. I know, and that's fine. But if there's just one place that a vertical line hits the graph in more than one place, then it's not a function. Over here, I don't care if you draw a million vertical lines, every vertical line that you draw will only hit the graph one time. So yes, 37 does represent a function. And then 39 and 40. Now remember, if this ordered pair right here was colored in like that, then if I drew a vertical line like that right there, a very pitiful vertical line, but if I drew a vertical line, it would hit the graph here and it would hit the graph here. So the answer would be no. Okay? But because the graph is undefined, when I draw a vertical line here, it only hits the graph once. When I draw a vertical line here, it only hits the graph once. When I draw a vertical line here, it only hits the graph once. And so yes, this is a function. Over here it's yes, because every vertical line you draw hits the graph once. Even this vertical line right here, because the graph is undefined right here, here it is defined, so the vertical line hits the graph only one time. So yes, it's a function. Alright, I hope this homework help video has been a help to you. Call or email if you have any questions.